Manufacturing workshops in Pakistan are preparing to recycle discarded oil barrels to produce affordable and durable steel pipes. Although they lack advanced production equipment, their steel pipes are very cost-effective. The pile of 2,000 rupees worth of recovered scrap oil barrels in front of them is the raw material for making steel pipes. To process them through machines, workers must first pre-treat the oil barrels. The primary purpose is to lay the barrels flat. Given their skinny thickness, workers can easily separate the sides by tapping with a hammer and chisel. Since the area of the top cover does not meet the requirements for making steel pipes, workers also need to separate them at the seams. Barrels of this material and shape typically contain either flammable or combustible substances. To avoid safety accidents, cautious workers refrain from using cutting machines. The most primitive dismantling method is also the safest, as it reduces the generation of sparks. With their extensive dismantling experience, workers can quickly dismantle barrels like these. Following this, they directly press the semicircular shape with their feet, transforming the cylindrical oil barrels into rectangular steel coils. Since the dismantling process is purely manual, it results in uneven steel coils. The neatly stacked oil barrel coils must be reshaped using the factory's sizable rolling machine to meet the rigid requirements for making steel pipes. Under the pressure of two large rollers, the original anti-skid patterns on the barrel surface disappear. The surface still has the original factory's rust-proof paint, so workers immerse it in a liquid for soaking. After 2 rounds of soaking with paint remover and hydrochloric acid, the rust-proof paint on the surface can be removed entirely. Since the surface is covered with hydrochloric acid liquid, continuous rinsing with clean water is necessary to prevent skin burns upon direct contact. After completing the surface cleaning, as one steel coil can produce multiple steel pipes, the cut steel coil, with the spacing of the cutting machine's rolling cutter adjusted, becomes the raw material needed for one steel pipe. The pipe-making machine can only be manually fed since all the pieces are segmented and cannot be connected. With the operation of this worker, the rollers driven by the transmission shaft continuously push the cut steel coils forward. Although their equipment is relatively outdated, their shaping rollers have no issues. As all the rollers gradually decrease, the steel coils that slowly overlap need to be polished with a grinding wheel to smooth the joint cross-section. This is to prevent uneven edges from affecting subsequent welding. After 3 repeated grinding passes, the steel coils, now squeezed to fit snugly on both sides, undergo automatic welding by a rolling welding machine. With heating at the front, these welded steel pipes become more sturdy and reliable. Since the steel pipes were preheated before welding, the welded joints can be reshaped and rapidly cooled through the middle water pipe during the second rolling process. These welded and reshaped steel pipes pushed out directly from the outlet may still have slight differences due to the cutting of each piece of raw material. Therefore, the finished steel pipes undergo uniform correction and manual quality inspection. Next, the steel pipes are pushed back into the shaping machine. With the continuous rotation of the concave rollers inside, the workers need to feed the steel pipes into it. At this point, the large number of shaping rollers inside the machine will cold bend the steel pipes. Despite having only 30 rollers, this low-end bending machine can correct even highly curved steel pipes, let alone these newly produced finished steel pipes. After 5 seconds of reshaping, the final usable products are the steel pipes pushed out from the outlet. Thus, the steel pipes manufactured from discarded oil barrels in Pakistan have been successfully produced. The quality of steel pipes produced through this waste utilization technology in Pakistan depends on various factors, such as the precision of manual labor, the efficiency of equipment, and the thoroughness of quality control. However, given the resourcefulness and dedication described in the process, the quality is likely to be reasonably good, meeting the local demand and providing a cost-effective solution.